The second kind of anomaly is an update anomaly, and this occurs when there's a change to the value of an attribute. But that change has to be made in multiple places. We've already seen this. This is the issue of redundancy. So you have the same attribute having occurring in multiple locations and with the same value. And when you change that value, you need to go and change it in multiple places, which is never a great idea. So if you do that, then you're going to have possibly have redundant data and inconsistencies in the way your queries are answered. So let's take an example. So we've already seen this, but let's take a look at it again. We have a course table over here. The course table contains the course number, the name, the room, and the seats. So what we're doing here is we are taking the room and the seats, this stuff over here, and what we're really modeling here, if you think about it, is a relationship between the room and the number of chairs in the room, right? So if you think of the number 60 in our example, the 60 is not an attribute of the course C4. It's not an attribute of this. It's an attribute of this. So we have inside here what's in database terms called a dependency. What we're saying is that the number of seats depends on the room number. It doesn't depend on the course, because the course can be switched to a different room, right? So that's the reason why we have this repeating redundant field in our table, right? Because we really have a dependency that is between two things that are not really what the table is about, right? That's the thing. The table is not about the room and the seats. It's about the courses. So what happens, of course, here is that if we change this 60 to 70, and we ask the question, how many seats are there in room 1127? We're going to have a problem, because if our algorithm that looks at the table, and we don't have control over the way SQL actually is executing the tables, the queries. If it looks at the query by searching top down, then it's going to say 70. On the other hand, if it looks at the query bottom up, it's going to say 60. And we get two different answers for the same question. Not a good idea. Okay, so how do we deal with this? Well, pretty straightforward. We know that our problem is occurring because the number of seats depends on the room, not on the course, right? The dependency is going this way. From the seats depends on this and does not depend on this. Therefore, what do? We take this out and make this into a separate table. So now we have a table that has room number, the number of the room, and the number of seats in the room, etc. And we're all set. Because now if we want to change the number of seats, all we need to do is go in here and replace the 60 by 70, and there's no other place where the number of seats is listed, so we are all set with that. So this is a straightforward way of doing it, but we can see again the reason that this happened was because there was a dependency between one column, in this case in our example here, between the seats column and something that wasn't really what the table was about, right? And in a more formal sense, we are saying that there's a dependency between seats and something, room in this case, that is not a key for the table. The key for this table is course number. It's not the room. In fact, the room you can see occurs numerous times, 1127, 1127, 1127. So it's not a key. And we have a dependency between seats and something that's not a key. That's the formal way of saying it. But in a more informal sense, what we're really saying is that we have here seats that depends on something that is not what this table is about. So that's why we're getting this problem. So that's update anomalies. And then the third kind of anomaly is what's called a deletion anomaly. This occurs when deleting something from the database results in some other possibly important fact being deleted. So that you take something out of the database and something else that is important also goes away, right? And we can see actually, if you think back to our tables, we see many such examples. So if we do this, what will happen is that we end up losing data. Just a simple example, if we go back here and I delete information about, like say, if I delete course C3 from this table, not only do we lose information about course C3, but we also lose this relationship between the room and the number of seats. Once I've deleted that, if I have a question like how many seats are there in room 331, I can't answer it, right? It's not there in my database anymore. So that's a really bad thing. You don't want to lose information. So going back to our course over here, our example over here, let's say we have our table which has 4 columns, 4 attributes, and in the course number, the name of the course, the room number the course is in, and the enrollment in the course. Okay, so the enrollment in the course means the number of students who are enrolled. So let's take a look at the first course number 1. There are only 6 students enrolled. Okay, data analytics in Python or data whatever, right? There are only 6 students enrolled in that class. So the university decides it's not cost effective to hold a class with only 6 students. So let's fire the professor and close this class down. So that class gets closed down. And what that means is that this row vanishes from our table. But not only are we losing the enrollment or that kind of information with it, but we're also using other information, which is not exactly over here, but should be, is things like the course description. What is the long description of the course? What are the ratings of the professor? Maybe they didn't fire the professor, but they kept him on. But his or her ratings are useful information. So that's also gone. Maybe over here we had columns that said ratings, description, okay, previous enrollments, etc. Right? All kinds of stuff. That's all gone. So we lose a lot of information when we delete an entity or a thing from our database, an item from our database. And the question is, are we structuring our database so that we don't actually lose the information that we don't want to lose? We only lose information that we don't care about. So in this case, it will be, again, fairly straightforward, because what we're really doing, if you look at our table here, is our course table contains, in this structure, and this is a really artificial structure, so forgive me for that, but in this structure, what it contains is information about the current occurrence of a course. If we don't offer a course this semester, that course doesn't exist, which is not really a reasonable thing to do. So what we need to do is we need to say, hey, we need to take out the listing of courses that exist separately and courses that are currently offered and keep them separate. Okay, we don't want them to be in the same table. They're linked by the course number. So that's our link. Okay. So the course number links these 2 tables together. But all information that needs to persist is contained in this table, and only current enrollment information and the current room number is contained in this table. That's the idea here. Okay. So that would take care of the deletion anomalies. So what we've done is we've taken courses and offered courses and separated out these 2 tables and made them into independent tables, so that this is the persistent table and it will contain the information forever. And this table is our current enrollment or current offerings table, and it contains only the current information. Now if we decide to scrap this class, we can do it without losing any meaningful information. Okay, that's the goal there. So if we can remove all these anomalies, then we are in a position to say that we have what's called a normalized database. And the database normalization is the process of removing these things. And again, we are not going to database theory over here, but just to be familiar with the terminology, we say that a relational database can be in any one of these forms: first normal forms, second normal forms, third normal form, Boyce normal form, and fourth normal form, and there's actually another form as well, but let's stick with this. And generally, if we are free if we've gone through this process of removing anomalies, if we are free of these 3 kinds of anomalies, then the database is said to be in 3NF, or third normal form. I'm not going to study the normal forms here. It's a reasonably comprehensive piece of literature, but you should be aware they exist. And when you're designing a database of your own, you should think about these issues, whether, how do we get rid of these 3 things: insertion, updation, and deletion anomalies. And if you can think about this and get rid of them, then you're in pretty good shape.